Welcome back to NRM 638 Python Scripting for ArcGIS Applications, Spring Semester 2015. This is an e-learning class at the University of Alaska Fairbanks. Okay, in this session what we're going to do is work on retrieving information about rasters. So if you go to the Blackboard website for this week, download week 3 listing information.zip and unzip it, and you'll have 3 rasters: depth, Fairbanks 250k.tiff, and leaf centimeter.tiff. So the first thing we'll do is we'll set our arcpy.environment workspace to this folder. So from the catalog window, I'll drag that folder into my Python window. And then we'll create a list of rasters. That would be arcpy.list rasters. Okay, so like list feature classes, we could put a wildcard and a raster type. So in this case, I'll just get a list of all the rasters in my workspace, and I'll put that in a list rasters container. So then what is the type of list raster? So it is a list, and then what's inside that container? So we've got these Unicode strings: depth, Fairbanks 250k, and leaf centimeter. Okay, so we'll work with each of these. We could loop through and print out the name of these rasters, for example. So for raster in my list of rasters, and the raster is just a Unicode string in this list. So here are the 3 strings in the list: depth, Fairbanks 250k.tiff, and leaf centimeter. Okay, and we'll work with each of these rasters. Okay, so insert a new data frame and then add depth to your new data frame. So depth is going to be from a location in Prince William Sound, the depth of every pixel, where sea level would be 0 and negative 371 would be the deepest pixel in this raster. And if we right mouse click on depth, we've got some properties that we could retrieve. So we could retrieve where the data source are coming from. So we'll do that next. Okay, so from my list of rasters, I took the first item in the list, and now we've got this variable called depth raster, and it contains this Unicode string. And just like when we were working with feature classes, we'll use the arcpy.describe function with our depth raster to create a describe object. So what is the data type? So in this example, it's a raster layer because I have it in my table of contents. And what is the path? So I press the up arrow key and give me .path. So that's the folder that raster is sitting in. And then press the up arrow key. And what is the base name? So depth is the name of our raster. And then what is the catalog path? So I press the up arrow key. And then what is the catalog path? So that's the full catalog path to that raster. Okay, if we look at the properties of our raster, we also have things like columns and rows, the number of bands. So the number of bands would be how many values are inside every cell. And then the format type, which is a grid, and then the pixel depth, which is 32-bit floating point. So we could also retrieve those types of properties. So width would be the number of columns. Height would be the number of the rows of that raster. So our raster is 1133 columns and 781 rows. So columns and rows. And then number of bands would be how many values are inside every pixel or every cell. There is indeed one value inside every cell. And what is the type? So I press the up arrow key and then pixel type. So it's floating point 32. So each value inside the grid cell is a floating point value, and it's 32 bits. And then what's the format? So it's a grid. So it's an ArcInfo grid format. Okay, we could also get, just like we did in feature classes, we could get the extent by creating an extent object. We could get the spatial reference by creating a spatial reference object. And here's something that's new is we could get the statistics. So what's the mean pixel value, the maximum pixel value, the minimum pixel value, etc. So to get the statistics, we need to make what's called a raster object. Okay, so to make a raster object, we're going to use arcpy.raster and then a string, which is that raster object. And in this case, we could say depth, or we could drag from our catalog the complete path to that raster object. It doesn't really matter. So now we've got a raster object. So then what is the size of this raster object in bytes? So then uncompressed raster size. So that's the size in bytes of our depth raster. And what's the pixel size? So how wide or how high is every pixel? So I press the up arrow key and then dot mean cell height or mean cell width. So it's 10 meters wide by 10 meters high. And if we look at our raster properties, it is indeed 10 by 10. Okay, so what's the mean pixel value? So that would simply be a raster object dot and then mean. So that's the mean pixel value. And what's the standard deviation? So once again, raster object dot and standard deviation. And we could do the same thing, dot minimum, dot maximum. Does this raster have a attribute table? So has raster attribute table? False. So this raster does not have a raster attribute table, and the reason is it's a floating point raster. So the only way you can have a raster attribute table is if it's an integer raster. And we could basically use a check. So dot, is this raster an integer raster? If it's true, then we could build a raster attribute table. If it's false, then we cannot build a raster attribute table, and it is false. Okay, so now let's make a new data frame, and we'll put our second raster in our new data frame. So our second raster is Fairbanks250k.tif, and that's a scan map or a digital raster graphic. So we could zoom in, and it's the Fairbanks 1 to 250,000 scale scan map. Okay, so we'll make a raster object from the second item in our list, which is this Fairbanks250k.tif. And then does that have, is it integer? So it is integer, so we could build a raster attribute table for this raster object, and we could check, does it already have a raster attribute table? So raster object dot, and does it have a raster attribute table? And it does have a raster attribute table. So we could open it, and there's our raster attribute table. And we'll access this raster attribute table in our next video session, which will deal with tables. Okay, so this is an integer raster. So what is the pixel type? So it's 8-bit. So this is basically unsigned 8-bit integer inside every pixel. So if we look at our properties, it is 8-bit and it is an unsigned integer. And what is the format property of our raster object? It is a TIFF. And indeed, this is a TIFF. And then what is the band count? So there is one value inside every pixel. Okay, our next raster will be a digital photo, so it will have 3 values inside every pixel representing the primary colors of red, green, and blue. So we'll make a new data frame and remove our old data frame, and then insert in this new data frame our third raster, which is a photograph, and it has no spatial reference, which is fine. So there's our photograph, and if we look at the properties, we've got 3 bands. So the number of bands is 3. And we'll make a raster object from this string leaf centimeters.tiff. And then we could say, okay, for this raster object, what is the band count? So it is a band count of 3. Okay, we can access the statistics for any band. If you go to catalog, you notice we've got band 1, band 2, and band 3. Let's make an object, let's just make it band 2 raster. So that's going to be equal to arcpi.raster. And then we'll drag band 2 into our Python window. So to access a band, it would be the name of the raster, and then a backslash, and then the name of the band that you're trying to access. So now what is the mean value for band 2? So band 2 raster.mean. So 169.15. And what's the maximum value for band 2? So 255. And if we look at our properties, we've got statistics, and here's band 2. So the mean was 169.15, and the maximum was 255. Okay, so if you go to the Blackboard website, I've got a quiz question for you that will lead you to the next video session, which will be working with tables and fields.